We're definitely talking about a once-in-a-century project here. It's not like building tracks in the open. The logistics have to meet the specific challenges posed by this tunnel. Like engineering a Swiss watch, this is precise track construction, right down to the millimeter. "5 a.m. We're in Biasca in the Ticino, Switzerland. Here in the West Tunnel, the non-ballast track on which trains will travel beneath the Gotthard from 2016 onwards at speeds of up to 250 km per hour is now almost complete. Metre by metre, the track layers work their way into the Gotthard Massif. This is what they find there, the exposed base of the rough work. The shift begins. The team whose job it is to install the rails along the route are under pressure. The minutely planned project schedule allows the men just 2 shifts to lay over 2 kilometers of rail. The special feature of this installation method is that the men from the track-laying train themselves lay the track they're actually moving along. All the machines and wagons they need for this are made ready during the night at the specialized loading terminal outside the tunnel. One day, high-speed trains and goods trains will travel along these rails. The track lifting and welding unit has been developed for the Gotthard for the first time. In our case, it's travelling on crawler tracks, and the advantage is that we can use this unit to lift the long rails and also weld them at the same time. The rail lifting unit pulls the 120-metre-long rail pairs into the correct position via temporarily installed rollers. Here, the crawler tracks have to be very precisely controlled. Each of these rails weighs over 7 tons. At the 120-metre mark, the lifting unit stops. Even now, the rails are almost at their place of installation. In the next phase, the machine lifts them from the transport rollers and places them on anchor arms. The installation team are making good progress. To maintain the high speed, work phases are always carried out parallel to each other. While the temporary track for use by the concrete train is prepared, a further team are already working on precise alignment of the rail joint geometry. During welding of the rails, the vertical and horizontal positions of the rail ends are only allowed to deviate from each other by a few tenths of a millimeter. The men are highly experienced, and adjustment takes only a few moments. The automatic welder is integrated into the rail lifting unit, and in just a few seconds is ready for operation. The rail ends are precision clamped inside the welding head and then pressed together. Many kiloamperes of electric current flow across the contact surfaces and heat the rail ends until they are white hot. They are then flash butt welded together. The rail joint can be travelled on again around 15 minutes later. Right now we're moving the rails forward again over the track which has already been welded, so very soon we'll be able to lift the next 120 meters. One day later, delivery of the sleepers for the future track. The rails will later be mounted on these sleepers. The workers unload 7,200 of them in 2 shifts, starting at the rear of the line, several kilometers inside the Gotthard base tunnel. This keeps the track along which the transport moves constantly free for unloading. The gantry crane with laying beam places 60 sleepers in one operation. The slotted wagon enables the crane to reach the base of the tunnel through the rails. Each sleeper is precisely positioned. The track layers who will be taking over at this location in 1 day's time are relying on finding a perfectly prepared construction site. Construction of the fixed track in the Gotthard base tunnel succeeds because of the optimal interplay of all work processes.
Für das Fahrbahnsystem an sich haben wir
We had around 100 planners working on the track system as such. Every move connected with track planning at the Gotthard, whether it was the planning of points or of non-ballast track, crossed our desks and was verified by us.
und wurde durch uns verifiziert.
The requirement is a mighty one. 57 kilometers of fixed track in each tunnel tube, with precision down to the millimeter. Machines lift the rails and bring the sleeper system into the correct position. All the rail and concrete placement operations have to be carried out with millimetrical precision. Degrees of inclination are measured in tenth of a degree increments. This is engineering skill with Swiss watch precision. The finishing touches are provided by the specialists from the slab track construction team. Only when the gates are closed does the robot shift a short distance further forward to place the next sleepers in position. 2 out of a total of roughly 380,000 in the entire Gotthard base tunnel project. We have a classic line construction site. We have 85 workers in a 24-hour, 7-day shift model. Here, in contrast to industrial production, where the material moves past the worker, our workers move along the line. The third section of the track-laying machine follows. These men are already putting the rails in their approximate final position and also fixing their height. The reference points for this are placed in the shoulders. The track layers use these reference points to precisely determine the position of the laying machine, thus already aligning the track to within tolerances of a millimeter. Then they align the rails with an inclination of exactly 1.45 degrees. Like this, meter by meter, they work their way into the depths of the Gotthard, roughly 200 meters per shift. After the track layers come the surveying engineers. We have tolerances down to the millimeter. The left and right rails are inclined inwards in a ratio of 1 to 40. The wheel thus constantly wants to move up and down, and it moves in a so-called hunting oscillation on the rail. Concrete experts from 6 countries use a special train to produce fresh concrete directly in the tunnel. Altogether, we have 15 wagons of aggregate on the train. Each wagon is filled with a mixture of sand and gravel. At 33 tons per wagon, that adds up to a total of around 500 tons. And all of that is processed in 2 8-hour-long shifts. The mixing wagon is at the head of the train. Parallel to operation, a master mixer coordinates the concrete consistency with the climatic conditions in the tunnel. The idea with the concrete train in situ is fantastic, of course. On the screen, we have a complete overview of the plant. On this belt, I can see the concrete falling into the storage container, and just by looking at it, I can tell whether its spread is wide enough. So concrete is produced continuously on a just-in-time basis. 20 minutes after its production, the fresh concrete is at the installation site, according to precisely defined recipes. Placement of the fixed track in the Gotthard base tunnel comprises around 20,000 working operations. For instance, this is a rolling installation plan. It goes directly to the construction site and with which the foreman and also the polishers work on site. The mixing plant remains in unceasing operation for 2 shifts. A construction materials tester subjects each batch to a precise examination. With a consistency of C25 to 30, the concrete has to spread to a width of at least 50 centimeters on the test area. The results of the test are documented and reported back immediately to the master mixer. The concrete transporter now gets the green light for the trip to the placement site. For this project, we have a figure in the triple-digit millions available, a budget that's constantly checked on. We completed procurement within 1 year, giving us price stability, and just-in-time delivery is also contractually fixed. A shuttle now takes care of the transport through the tunnel, using the shoulder as a track, thanks to a special solution. Steered by gauge wheels, monitored on 4 redundancy levels with ultrasonic sensors. The minimum setting time for the concrete is 48 hours. During that time, the concrete train cannot use the track. This is why the concrete has to be supplied in portions. The transfer from the transporter to the placement station is timed to the minute. In this way, within 1 hour, roughly 15 cubic meters of fresh concrete can be produced, supplied and processed. There are no stops of any kind. Even the shift changes are seamless. This is because the quality of a fixed track largely depends on continuity of placement. First, the workers compact the concrete with so-called shaker bottles. The vibrations help to prevent bubbles of trapped air. With fixed tracks, it's always an interplay between man and machine. For 57 kilometers of tunnel, they have to optimize that interplay absolutely. For this purpose, we've built a 240-meter-long test track outside the tunnel to train every single working operation, so that we can guarantee 100% quality from the first meter on. Around 200 meters of fixed track are produced by the men in 2 shifts that interlock seamlessly. The track can be built in one single industrial process. At the same time, only manual work can achieve the very highest quality standards. One example being the smoothing of the concrete. Manual work is still essential. We have to guarantee a 0.7% inclination in the straight sections too, so that we can remove any water caused by damage or seepage. The engineers have succeeded in improving the entire installation system on a continuous basis. Today, the interplay of man and machine has achieved the highest installation quality, outstanding safety at the individual workstations, and a highly impressive working speed. We're seamlessly integrating the Gotthard base tunnel into the rail network of the SBB. They have established timetables and times, and these access routes are agreed on in coordination discussions and then installed. The Gotthard base tunnel, the largest infrastructure site in Europe. At the kilometer 256.3 mark, its final inspection. Surveying engineers and quality inspectors check every meter of the completed track. If they find any deviations from the tolerances, the track has to be torn up again. But the results are correct. Millimetrical precision for a once-in-a-century project. The track is ready for operation at 250 kilometers an hour. Sustainability is an important aspect of this project, and so is the setting of new standards where work safety and environmental protection are concerned. Only 25 workers per shift are required to guarantee production of the fixed track. The men on the late shift take over, and when it ends at around 10 p.m, they travel with the concrete train to the loading terminal on the south side of the Gotthard. For the men, the day's work is over, but in the hall, operations continue. The train now has to be serviced, filled and cleaned, and made ready for use again in 6 hours' time. 450 tons of additives, 90 tons of cement, 50 cubic meters of water and 1,000 liters of aggregate to mix into the concrete. Loading is automated, and parallel to it, the mixing and pumping unit is cleaned and serviced every night. Together with the partners from Switzerland, the objective has been clearly defined. In 2016, the first train will pass through the new tunnel. Then the way will be clear for a fast connection between Northern and Southern Europe.